fourth lecture we gonna learn about the probability distribution. However, the probability theory is known to you in your previous class, but we assume that knowledge, but we give a very brief primer on what is the probability theory. Basically, the ideas of probabilities are certainly useful in different context. Basically, the word chance is a very common word. Suppose you are thinking about the weather forecast, it always predicts with some certain percentage of happening at a particular event, say a tornado or a rainfall or any cyclone. That is always predicted with chance. That is basically the basis of any weather forecasting. But in physics, we use the theory of probability, certainly useful, because we know the kinetic theory of gases already. The ideas of probability are certainly useful while describing the behavior of 10 to the power 23 number of molecules, that means Avogadro number of molecules. Such a number of molecules, you cannot write the Newton's equations, Newton's laws, Newton's equation for 10 to the power 23 number of molecules. That is impractical for us. Rather, we give some probabilistic description. In that situation, we give, suppose what is the probability that the certain molecules having velocity v to v plus dv. What is the probability of getting that number of molecule with certain probability? That is v to v plus dv. That is the way we deal the kinetic theory of gases, and from there we can deduce the equation, the pressure, the expression for pressure. In one hand we have a microscopic variables, on other hand there is a macroscopic variable, that is p, and we connect these both two and we give some so we describe the behavior of the gases, rather the ideal gases, in this probabilistic description, and that's why the Jesse and that discovered that distribution, the velocity distribution or speed distribution of gas molecules, ideal gas molecules, was given by the Jesse Maxwell. And true logic of this world, and he said the true logic of this world lies in the calculus of probabilities. Any physical theory is a guesswork, and theory of probability is a system for making the better guesses. And in one hand we had a classical theory. The classical theory always says deterministic, which is a deterministic. Suppose the Newton's law, it predicts the future of any particle, the trajectory of the particle with infinite accurate. That is completely accurate. That means the position of the sun and earth, if supposed to be 100 years later, what will be the position of earth or sun, whatever according to Newton's law, that is a fixed quantity. That is there is no guess kind of thing. That is basically the deterministic. But the theory of probability always works with it is not a deterministic, that is a deviation from deterministic, the loss of certainty in the theory of probability theory, in the probability. And the nature itself is a very much rather I would say the nature is basically not certain, so to say. If we know the basics of quantum mechanics, that is known to us, the position and momentum of a particle cannot be determined with infinite precision. That means the atomic happenings cannot be described with deterministic mechanics. Here comes the probability theory, and so there is a certain probability, that means there is uncertainty in specification of the position and momentum of a particle. That is a very troublesome at the time, at the time of birth of quantum mechanics, because Heisenberg uncertainty principle gives you the delta x delta p is greater than or equal to h by over 2. So you cannot pinpoint the position and momentum simultaneously, and that is some kind of loss of certainty in physics and uncertainty principle describe an inherent fuzziness that exists in any attempt to describe nature. Our most precise description of nature must be in terms of probabilities. There are some people who do not like this way of describing nature. They feel somehow that if they could only tell what is really going on with a particle, and they could know its position and speed simultaneously. In early days of development of quantum mechanics, the great Einstein was quite worried about this problem. He used to shake his head, say, surely God does not throw dice in determining how electrons should go. He worried about the problem for a long time, and he probably never really reconciled himself to the fact that this is the best description of nature that one can give. There are still one or two physicists who are working on the problem who have an intuitive conviction that it is possible somehow to describe the world in a different way, that all this uncertainty about the way things can be removed, and no one has yet been successful till now. The great mathematician and physicist Jesse Maxwell told, the true logic of this world is in the calculus of probabilities. Any physical theory is a kind of guesswork. Theory of probability is a system for making better guesses. The probability of a particular outcome of an observation, we mean our estimate for the most likely fraction of a number of repeated observations that will yield that a particular outcome. That means if n is the total number of observations and na the favorable and most likely observations, okay, and that is the probability of that event A, PA can be written as NA divided by N. And here in the basic definition, outcome must be equally likely, and the repeatable observations are important. The main objection is no situation is exactly repeatable. Repeated observation means an appear equivalent. Suppose this is a random experiment. Suppose the coin tossing. A fair coin and unbiased coin is tossed, then head and tail, both the events and both the face will appear without any bias. That is coin tossing and an experiment, die tossing, coin tossing, etc. And both are repeatable. That I can toss many times. So head and tail appear with chance of probability, and there is two event, that is two number of that means observation is 2, and particularly the probability of head is a 1, the 1 by 2, that is probability of head is half, and probability of tail is also is half, and die tossing, etc. These are random experiments. And we just discuss about the coin tossing experiment. We toss a coin twice. It should be honest, that is unbiased. We assume tail equals to 0 and head equals to 1. The sample space, this is called the sample space. So as shown in the figure, it is a finite sample space. Coin tossing is a trial. It is in probability. The word trial is used. Tossing a particular coin repeatedly is called the random experiment. That means here the sample space is supposed to be twice, maybe 0 0. That means both is tail. Both the happening is tail. First toss the first is head, then tail. Head might be tail head. This is the total sample space. And we just give you in this way. Writing in this way, random experiment, an unbiased coin is tossed 5 times. Right, unbiased coin is tossed is 5 times. That means that is basically here trials are independent. N equals to 1, 2, 3, 4, 5. The first outcome, the head, appear head. The cumulative frequency, that is 1. The relative frequency, the happening divided by total, 1. The second toss in the second trial, that is tail. The cumulative frequency, the first tail, that is 1. But total number of trials is 2, 1 or 2.5. The third trial, this is basically head. So number of heads cumulatively, 1 and this is head, that is 2. But total number of trials is 3. from the beginning 2 by 3. In this way, the fourth trial, it appears head. That means the number of heads till now is 3. Total number of trials are 4. So 3 over 4, 3 by 4, that is 0.75. And the fifth trial, it is tail. That means the number of tail is 2, that is 0.4. We did the unbiased coin tossed experiment in a computer, and this experiment, and this is plotted here. The first toss is tail, this, and second toss head, tail, head, tail, tail. And if we plot the relative frequency as discussed in the previous slide, this is something like that. If we increase the number of trials, this thing, this curve, the relative frequency curve, will look something like that. And previously there are 6 trials. Now in this experiment there are 100 trials. The relative frequency is becoming reaching the value the half, as because the number of trials are increasing. And if we if the experiment number of trials is almost 100, that means 1001 number of trials, then the relative probability is almost reaches the half value. Almost it goes around the 0.5. It centers around oscillating between 0.5 almost, and it becomes almost 0.5. And if you 10,001 experiments, random experiments, it is also, these pseudo random numbers. We did the experiment with pseudo random because computer generates always pseudo random numbers. 10,001, and this is almost reached the relative probability is almost half. This is known as the statistical regularity. From this computer simulation experiment, it is clear that the number of trials increases, the relative probability tends to half. The relative frequency becomes stable in the long run and approaches a limit. This stability is the basis of any probability theory. This is known as statistical regularity, and this is the basis for any insurance company to calculate its premium. Suppose ordinary is a very good health, having a good health person. Suppose he is suppose the age is 20 years or 30 years, the premium is very low because the probability of getting illness is very low in general setting. But it is not valid in a pandemic situation like COVID-19 or any other epidemic situation, because in epidemic or pandemic situation large number of people are getting affected. So that's why any insurance company not giving that is done previously non-pandemic or non-epidemic situation, that is not covered, this kind of because that is the calculation is based on a general setting. There is no epidemic, no pandemic, no particular kind of thing. So back to the example. So suppose the age is 20 or 30, the premium or the sum assured amount of money if you are getting illness by accident, if that is very important, if you are getting any illness by an accident, then you will give some amount of money from the insurance company if you give the premium, and the premium is very low for the age 20, 30 or 35 or 5 years old. For as the age is increasing, if you go to the chart of the life insurance company, then as the age is increasing, the amount of the value that you have to give every month or every year or bi-monthly, whatever maybe that is very large. It because the probability analysis, the risk analysis, the how much risk is associated with that person, because suppose the 100 or 1000 people are with the company, particular company, insurance company, life insurance company, then if the most of the people are getting affected, they will run out of their funds, because everybody is getting suppose the amount stored in your account is suppose 1 lakh, but the sum of assured money is supposed to be 30 lakhs or 20 lakhs or 5 lakhs or 2 lakhs, but that is not the amount that is stored. It is based on chance, because not every people will not getting affected by the disease. So total money collected by 10,000 people, 10,000 by 1 lakh customer, will be used for a particular 3 or 4 or 5 or whatever certain percentage of population, because it based on the statistical regularity, that is how, for a particular population how much people will be affected by these by any diseases. That is a statistical regularity that is not included the epidemic or pandemic like situation. That's why that insurance company will not give any security in that situation. And basically any random experiment, we always seek for a random variable. Random variable means, suppose we are, because we are studying physics, that's why I am give physical example. Supposed to be the molecule within the ideal gas, the velocity of a particular molecule c to c plus dc will have the probability distribution fc. Here fc is the probability distribution function and c is the random variable, because c can take a value depending on the chance, because velocity is randomly distributed. That means it is a continuous kind of thing. Velocity can be anything from 0 to infinity in that setting, so it is a continuous. Suppose a discrete random variable, discrete, that means the values are not continuous kind of thing. That means it happens supposed to be the coin tossing experiment. Here the head or tail, it is a discrete random variable. And there are other kinds of variable that is not our in our discussion. And in a continuous and discrete random variable, in both the situation it should be discrete also. PDF exists, PDF probability density function, PDF may not exist. It should valid for continuous and discrete both. I am just giving the continuous case only, but that is not generally true, because discrete most famous discrete random variable is a binomial distribution, but that will be discussed in a later classes. And from any random experiment we collect some data, that means and from there we try to identify what is the random variable, and which one random experiment will allow us to do some random variable, and random variable what is the distribution of that random variable. We always search for the distribution. If we know the distribution, then the analysis of that particular event will be great helpful for us, mathematical analysis.